Okay, in the last section of videos, we talked about the addition property of equality, and we talked about that you could add anything you wanted to both sides of an equation, and that would maintain balance. So we're still thinking about that giant balance here. We could put anything we wanted to on both sides as long as we did it to both sides, and it would maintain that balance. Well, if you think about multiplication, multiplication is just addition over and over and over again. So really you are just adding things to both sides of the equation. Now, we call this the multiplication property of equality, and let's see how this works. It sounds a whole lot more confusing than what it really is. So let's say that we have this problem right here. We have 5x equals 20. And keep in mind what we're supposed to be doing. We're supposed to be solving for x, which means that we want to know x equals something. We want to know what it actually is. Well, right now we have 5 times x instead of just a plain old x. Well, remember that in order to remove things from x, to get them away from it, we always do the opposite. So think about what's going on here right now. We have 5 times x. So what would be the opposite of multiplying by 5? Well, that would be to divide by 5. And I can do that as long as I do it to both sides. That way I've maintained that balance. And I know that our property doesn't say anything about dividing, but multiplying or dividing by the reciprocal are the exact same thing. So really what we're doing here is we're actually multiplying both sides of this equation by 1/5, which is the same thing as dividing by 5. Alright, so when we do this, 5 divided by 5 is 1. So all we're left with on the left-hand side of this equation is x equals, and on the right-hand side we have 20 divided by 5, which would be 4. So our answer would be x equals 4. Now we can always check these problems very quickly and easily, because if we said that x was supposed to be 4, then that means we should be able to plug it in place of x here, and it should make a true statement. So if what I've done is correct, then 5 times something should equal 20. Well, I'm saying that that something is 4. And actually that is true, isn't it? Because 20 equals 20. So we can check each and every one of these problems. Now let's try another one here. Here we have negative 3z equals 12. And again, we want to get the letter or the variable alone. So we have to look at what's going on between it and the numbers that are with it. This says negative 3 times z equals 12. Well, what would be the opposite of multiplying by a negative 3? That would be to divide by a negative 3. The opposite of multiplying is dividing. We can do that as long as we do it to both sides. Now, negative 3 divided by negative 3 is 1. So on the left-hand side, we would have z and then equals. On the right-hand side, 12 divided by negative 3. Well, remember, we have to do our positive and negative rules here also. Positive divided by a negative is a negative. 12 divided by 3 would be 4. So we're saying that our answer here is z equals negative 4. And again, we can check this by taking our answer and our solution and plugging it back in place of the variable. So we're saying negative 3 times something should equal 12. Well, we're saying that something should be negative 4. Is negative 3 times negative 4 a positive 12? It sure is. So this checks.